Okay, for number 12, you pick a side to work on and make it look like the other side. That's what it means to verify the identity. So because on the left side I notice that it has this trinomial squared, I'm going to go ahead and work on the left side. On the right side there's nothing to combine, nothing to multiply out or anything, so I'm just going to leave the right side alone, and my goal is to make the left side look like the right side. So I'm going to set up, because remember this is x plus y plus z times x plus y plus z. So I'm going to set up a little 3 by 3. And set up my terms in there, or on the outside. This is a multiplication chart, so x, y, z, and x, y, z. We're multiplying together. So here I have x squared, xy, xz, and even though y is first on the left side, I'm going to write it as xy, just so that it's in alphabetical order. So y squared, and then yz. The third row, xz, yz, and z squared. So if you look on the diagonals, I have a few like terms. So right here on this diagonal, I have this one and this one, like terms. This diagonal, on the main diagonal, I have, they're not next to each other, but I have this one and this one are like terms. And then on the next diagonal, I have these two like terms right here. So now when you write out your answer, just to follow the same order that they have up here, I've got x squared plus y squared plus z squared, and then looking at the pink I have 2xy, and then looking at the green I've got 2xz, and then looking at the yellow I've got 2yz. For number 13, same thing. This time though I'm going to work on the right side, because the right side is the one that has a multiplication problem right here. I've got this binomial times this polynomial that's 5 terms long, and so my goal is to make it look like the left side. So I'm going to draw another grid. So this is going to be a 2 by 5. Put it right here. So 1, 2, 3, 4, and then one more 5. And then the a and b go on this side, and then the polynomial goes on the top. So a to the 4th negative a cubed b, a squared b squared, negative ab cubed, and b to the 4th. So we're going to multiply, right? So this is a to the 5th minus a to the 4th b, because it's a times a cubed b, and then a times a squared b squared is a to the 3rd b squared, then minus a squared b to the 3rd, and then a b to the 4th. And so we go to the next row, and now we're going to multiply b times each of the terms. So I've got a to the 4th b minus a cubed b squared, then a squared b to the 3rd, and then negative ab to the 4th, and then b to the 5th. So I'm going to take the highlighters to mark all the like terms. So notice here, these are like terms on this diagonal and they're opposites, so this is going to give you 0. Then you go to the next one. These are also like terms on this diagonal and they're opposite of each other, so when you combine them you get 0. And then you go to the next one, and so this gives you another 0 because they're opposite of each other. And then you go to the next one and you get another pair of opposites, like terms but they're opposite, so when you combine them you get 0. So now you're left with a to the 5th plus b to the 5th, which is exactly what you wanted to prove, that it equals this. For number 14, we're going to work on the right side because this is the one that has some multiplication to do. Over here, there's nothing I can do because they're not like terms, so I can't subtract them. I can't factor anything out because they don't have any common factors. So I'm going to just go ahead and multiply on the right side. So for starters, we will multiply these two first, and then whatever we get, we'll multiply by that. So x minus y times x plus y, that would be x squared, and I'm just using distributive property, so this times this, and then this times this, so plus xy, and now this times this, and this times this, that gives me negative xy minus y squared. Well, notice the two middle terms are opposites of each other and they cancel out. And so now we have x squared minus y squared, right, left. And we bring down the next factor, which is x squared plus y squared. Okay, so now when it's binomial times binomial, I usually don't do the grid, I just do distributive property. So this times this is going to be, put it on the next line, x to the fourth, and then this times this is plus x squared y squared. I put the square on the wrong side. Let me just fix that. And then I move on to the negative y squared. So this times this is negative x squared y squared, and then this times this is negative y to the fourth. So notice again, two middle terms are like terms and they're opposite of each other, so they cancel out. So we're left with x to the fourth minus y to the fourth, and there's exactly what we needed to show that it looks like that side. For number 15, I'm going to work on the right side just because there's a little bit more to do, because I've got to square each binomial and then there's a plus there that will tell me to combine some terms, whereas on the left side it's only multiply, and so I think that it'll be easier for me if I start on the right side. So I'm going to multiply out each binomial, so I get ax minus by. So I've set up the problem, I expanded it. Instead of having the square, I wrote out each factor twice, because that's what square means, right? So now we're going to do distributive property, so it's going to be this one times this one, so that gives you a squared x squared, and then this times this gives you negative abxy, and now this times this gives you negative abxy. Notice how I put the abxy in that order, as it doesn't matter how we multiply it, but the order I'm trying to keep the same. And then this times this would give me positive b squared y squared. So now I'm going to move on to the next pair of factors. So that's going to be this times this, so that's going to be b squared x squared, and then this times this plus abxy, and then this times this plus abxy, and then this times this plus a squared y squared. So we go through and see if we have any like terms to combine, and I notice that I've got a negative abxy and a positive abxy, so those cancel out to 0. And then I have another pair just like that, negative abxy, positive abxy. That gives you 0. So now I'm going to write what I have left. A squared x squared plus b squared y squared plus b squared x squared plus a squared y squared. And it still doesn't look like the left side on the original identity, right? I've got to factor somehow. So notice how these have the b squared in common and these have the a squared in common. So I'm going to go ahead and rearrange them so that they're next to each other. So I'll put a squared x squared and then plus a squared y squared, and the b's, b squared y squared plus b squared x squared. Okay, so now I can take them and do something called factor by grouping, which you've done in a previous class, but I'm going to review with you anyway. So here, you take them in pairs and you take out the greatest common factor. So in the first pair, they have a squared in common. And when you factor that out, this is what I have left. In the second pair right here, they have b squared in common. So I take that out, I factor it out, and so I'm left with y squared plus x squared. Now remember, y squared plus x squared is the same thing as x squared plus y squared. So this factor and this factor are exactly the same. So I'm going to factor it out. I'm going to take it out, I'm going to take it out. So when I do that, I'll take it out as x squared plus y squared. And then when I take it out of the first term out of here, I take this one out, I'm left with a squared. And then when I do the same thing with the second term, I'm going to take this factor out, I'm left with b squared. Okay, so just to make it look like the original, we just rearrange the terms, and I'm going to write a squared plus b squared first times the quantity of x squared plus y squared. So now we've completed the problem. So for number 16, they want you to use one or more of these identities. So here's one, here's another one, and here's another one. Okay, to solve this problem right here, to solve 43 squared. So if you look at the pink one, I can break up 43 as 40 plus 3. So I can write it as 40 plus 3. And then it's squared, right? That's 43 squared. Now this is like my x and this is like my y, so I'm going to follow the same, I'm going to follow what it says on the pink identity. I'm going to follow this side and do exactly what it says right there. So it's 40 squared plus 2 times 40 times 3 plus 3 squared. So that's 1600 plus 240, that's 2 times 40 times 3, plus 9. When you add the three numbers together, you get 1849. So 43 times 43 is 1849. I could also use the yellow one. I can use this one over here if I wanted to. But instead of 40 plus 3, I want two numbers that subtract to give you 43. So a combination you can use is 50 minus 7. 50 minus 7 is 43. And we're going to square it, right? So then it's going to be 50 squared minus 2 times 50 times 7 plus 49. 7 times 7 is 49. So then you get 2500 minus 700 plus 49. So 2500 minus 700 is 1800 plus 49 is 1849. For 22, they want you to see which student did the problem incorrectly and identify the error. So when you square a binomial, remember it's, let me write it like this. A plus b quantity squared would be a plus b times a plus b. So that's a squared plus ab plus ab plus b squared, right? So then that's two of these, right? So that's going to be a squared plus 2ab plus b squared. So the answer that matches that, the work that matches that, is this one right here. So this one's wrong, and the mistake that, it says identify the error right here. They put b squared. Okay, so it's not a squared b squared, it's just a squared. And then right here, the a0, a to the 0, b to the 0, that's one, that's wrong too. So they made two mistakes. For number 23, they don't necessarily want the answer. They just want you to tell how many terms you will end up with after you multiply.